Write a function rule for w of x if u of x equals x cubed plus 1, v of x equals x squared minus x, and w of x equals u of x plus v of x. Use a table and justify your answer. Okay, so let's go ahead and fill in our table. So for the x values, I'm just going to start at -2 and go up by 1. The important thing here is just to make sure that you include 0 and 1 in your table, and then make sure that you're going up by a constant rate of change or constant delta x. So notice that I'm going up by 1 each time here, and so that's important just because that makes sure that uh, this will be constant here. And so let's go ahead and fill in these, plug these into our functions. So if we plug in -2 to u of x, we get -2 cubed, which is -8, plus 1 is -7. -1 cubed plus 1 is 0. 0 cubed is 0 plus 1 is 1. 1 cubed is 1 plus 1 is 2. And 2 cubed is 8 plus 1 is 9. And then -2 squared is +4 minus -2 is +2. So 4 plus 2 is 6. -1 squared is +1 minus -1 is +1. So 1 plus 1 is 2. 0 squared is 0 minus 0 is 0. 1 squared is 1 minus 1 is 0. And 2 squared is 4 minus 2 is 2. So now we can just add these together. So we get -7 plus 6 is -1. 0 plus 2 is 2. 1 plus 0 is 1. 2 plus 0 is 2. And 9 plus 2 is 11. Okay, so now we can find the differences between the y values, and that lets us know what kind of equation it is. So going from the y value of the biggest x value, and then we're going to go down, subtracting that way. So 11 minus 2 is 9. 2 minus 1 is 1. 1 minus 2 is -1, and 2 minus -1 is +3. And then, so that's our first difference, and if those were constant, this would be a linear, but let's keep going since it's not. So 9 minus 1 is 8. 1 minus -1 is 2. And -1 minus 3 is -4. So again, these are not constant for our second difference, so it's not going to be quadratic. We can keep going. So 8 minus 2 is 6, and 2 minus -4 is 6 as well. Okay, so we see our third difference has the same constant difference, and so that means it's going to be a cubic function. So let's go ahead and use what we learned in chapter 1 to figure out what this equation will be. So remember that with a cubic, the standard form is ax cubed plus bx squared plus cx plus d. And we need to find those coefficients a, b, c, and d. So I have the bullet points here from chapter 1. So first of all, 6a will equal the third difference, which here is 6. So solve for that, dividing by 6 on each side. We get a equals 6 divided by 6, which is 1. Now to find b, we know that 6a plus 2b will equal the second difference, and that's between x equals 0 and x equals 1 as the x values get bigger. So second difference, as they get bigger, it's going to be 8. So we can solve this. 6a we just saw over here was 6 plus 2b equals 8. Solving, we can subtract 6 on each side, so we get 2b equals 2. Dividing by 2, we see that b will equal just 1. And now to find c, a plus b plus c will equal the first difference between x equals 0 and x equals 1. So that's going to be 1. So plugging in our values we know a is 1 and b is 1. And then solving, 1 plus 1 is 2 plus c is 1. Continue to solve for c, we can subtract 2 on each side, so we get c equals 1 minus 2, which is -1. And lastly, d will be the y coordinate of the y coordinate when x equals 0. So w of 0 is just 1. So we know that d will equal 1. And then plug those into our standard form, then a is 1, so we have 1 x cubed. B is 1, so we have b x squared plus cx, and c here is -1, so we can just do -1 or plus -1, and x, and then plus d, which is 1. So we don't need to, and we know that equals wx. So we don't need to put 1 as a coefficient since it is 1. So our final answer will be w of x equals x cubed plus x squared minus x plus 1.